this video, we're going to discuss arrays in Java. An array is a data structure that allows us to store multiple values of the same type. An array is essentially an ordered list of values, all of the same type, which is referred to as the base type. An array in Java can hold primitives like ints and booleans, or objects like strings or a data type of a class that you've created. To declare an array, you specify the base type, square brackets, and the array name. In this example, we've declared an int array, boolean array, and string array. Just declaring an array doesn't specify its size or create any elements inside it. It doesn't allocate any space in memory. To do that, you need to initialize the array. To initialize an array, you use the new operator, the base type again, and then the array size inside of square brackets. Initializing an array allocates a contiguous space in memory for this many elements of the base type. In this example, we allocate space for 50 integers and 100 booleans. You can also use any int variable for the size, such as num students. The newly created arrays are filled with a default value depending on the type. Each data type has its own default value. For example, the default value for ints is 0, booleans is false, and for objects, including strings, it is null. Along with the array, we also get an instance data variable called length. Length is the size of the array that you just specified, and you can access it through the name of your array.length. Note that once you specify the size of an array, you cannot change it. There is one other way to initialize an array when you know what you want to store in the array ahead of time, and that's with an initializer list. To use this, you follow the declaration of the array by curly brackets that contain the values separated by commas. This setup creates and fills the array in a single statement. The size, or .length, is determined by how many elements are in the brackets. You can use this setup if you have a relatively small array and you know the initial values that you want stored in an array right when you declare it. Note that you can only use an initializer list when you first declare the array. Each value in an array has a numeric index. The indices start at 0. The largest index is array.length minus 1. Be careful about this. Trying to access an array at index array.length will crash your code because that index is out of bounds. Also note that array.length is the capacity of the array. It tells you the size of the array, how many elements the array can hold. It doesn't tell you how many elements you've actually put into your array. There is no automated way to track that. Any single element in an array can be used just like any other variable of that base type. To access a single element in an array, you specify the array name and the index or position inside of square brackets. Remember that Java is strongly typed, meaning that a variable's type fully defines what you can do with it. In Java, all arrays are objects. So the array itself is an object. But the type of a single element within the array is the base type that can be primitive or object. An element of the array can be used anywhere that you would expect a variable of that base type to be used, including passing it as a parameter, using it in an expression, or using it to invoke a method. Note that the square brackets are used in 3 different ways when working with arrays. They're used to declare an array and to specify the size when initializing an array. They are also then used to access an individual value or element within the array. To store a value in an array, you put the array at index on the left side of an assignment statement. This is the same setup you would use to assign a value to any other variable. The difference is just that there isn't a separate variable name, but rather just an array and index number. Just like any other assignment statement, the variable goes on the left and the value goes on the right. We fully evaluate the right-hand side before storing that value into the variable on the left. Make sure that the value on the right and the variable on the left, in this case the base type of your array, are the same type. You can access each element in an array with a for loop. You can use a for loop to put elements in an array, retrieve elements from an array, and modify or update the elements stored in an array. It's best practice to design your for loop to start at index 0 and go up to less than array.length. This is better practice than hard coding a numeric size into the loop. It also helps avoid out-of-bounds errors. In general, be careful with array out-of-bounds and off-by-1 errors. Having your code crash with an array index out-of-bounds exception is always preventable. In loops, use less than and not less than or equal to avoid going out of bounds. You can also use a for each loop or enhanced for loop to access the elements in an array. The for each loop allows you to iterate over every element in your array without using the indices directly. If you only need to access the elements in your array and you don't need to store things or change what is stored, it's best practice to use a for each loop. Note that you cannot use a for each loop to change what's stored in the array, only to access what's already there. So if you need to store elements in your array, change what's stored in your array, access only some but not all of your elements, or use the actual array index, it's best to use a traditional for loop. But if you're only iterating over your whole array to access the elements, the for each is the best choice. Remember that in Java, arrays are objects. That means that the name of the array holds a reference or memory address to the place in memory where the array elements are stored. This is the value of the array variable. This is different from a primitive variable, where the value is just the data itself. For objects, the value is that reference or memory address. This is important when you pass an array as a parameter. Java is a pass-by-value language, so when you pass an array into a method, its value is passed, meaning that its memory address is passed. That means that the array being accessed inside the method is the same as the one passed in. There's only one array. So any changes made to what is stored in the array inside the method will affect the array outside the method because it's the same array. In this example, the numbers array points to a place in memory that stores 5 ints. We pass this array into the method. The method parameter, called numVals, is now an alias with numbers. They point to the same place in memory. So when we increment position 0 inside the method, it is changed for the numbers array outside the method to, because it's the same array. Because an array is an object, this also means that if you use direct assignment with an array, you'll create an alias, meaning you'll have two variable names that point to the exact same place in memory. Changing the array through one variable changes it for both because it's the same array. Using simple direct assignment with an equal sign does not make a copy of the array, it just creates an alias. The only way to make a copy is to use the new keyword and create a new array. You can then iterate and copy the contents from the old array into the new array. Remember that once you specify the size of an array, you cannot change it. If you do need a bigger array, you can use this copy approach to create a new empty bigger array. Then you can copy the contents from the old array into the new array. And then finally, you can assign that new array to your array variable. The value on the right, the memory address of the big array, is assigned to the variable on the left, your array variable. So the new bigger array is referenced by your variable, and the old smaller array will be released for garbage collection. You can also use a utility method in the java.util.arrays class called copyOf. This method creates a new copy of an array with either the same or a different length, including a bigger length, which allows you to do the same thing we just did in the previous slide. The arrays class also has a static toString method, which generates a nicely formatted text version of the array's contents. Note that unfortunately you cannot just put your array directly into a printline statement. You need to use this arrays.toString method in order to have a nicely formatted printout. And be careful to note that this is the arrays class. There is an S on the end. Java also allows two-dimensional arrays, which you can think about like a table of elements with rows and columns. Behind the scenes, two-dimensional arrays are actually arrays of arrays. Two-dimensional arrays are good for representing structures like grids and matrices. When you declare a two-dimensional array, you specify the number of rows and columns. You then access any single element with two index values, row and column. Remember that both the rows and the columns start at 0. You often will use a nested loop to access a two-dimensional array. The outer loop iterates over each row, and the inner loop iterates over all the columns in a single row. This has been an overview of arrays in Java. I hope it's been like a ray of sunshine in your happy coding day.